Hello friends and my dear students, I welcome you all to my channel. I hope you're all well and your studies are also going on well. This is part 10 video uh, from the chapter of force and pressure, where I will solve 5 multiple choice questions based on the concept of thrust and pressure of solids and liquid columns that I discussed in the previous video, that is part 9. If you find this video beneficial, then please like it, share it with your friends. And if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 10 video, where I will solve 5 multiple choice questions based on concepts discussed in part 9. Okay, so the first problem says that a cylindrical solid body weighing W kgf and density ρ1 kilogram per meter cube is immersed in a liquid of density ρ2 kilogram per meter cube, where it is given ρ2 is less than ρ1. That is, the solid body is denser than the liquid. If the body has a base area of a meter square, then the pressure exerted by the body on the bottom surface of the container is. Now, from the buoyancy, from the Archimedes principles and the floating and sinking of solid in a liquid, we know that if the density of a solid body is more than the liquid, then it will completely immerse. So the scenario will be, so this is the let's say liquid. The body will be completely immersed, and we know, since the density of the body ρ1 is greater than, since given ρ1 is greater than ρ2, the body will sink in the liquid. So this will be the scenario, and we know that when a body is inside a liquid, is immersed in a liquid, the buoyant force or the upthrust will act upwards, Fb, and the weight of the body will act downwards. So in effectively we know the apparent weight of the body inside the liquid will be Fw minus Fb, where W is the weight of the body in air. Now, what is W? It is given that W, the weight is already given to be W kgf. Okay. Can we find? We need to know Fb. To know Fb is the upthrust, which is the weight of the displaced liquid. So let's see what will be Fb. Fb will be the weight of the displaced liquid. What will be the mass of the displaced liquid? It will be the volume of the body. Since the body is completely sunk, the volume of the displaced liquid will be equal to the volume of the body. Now the volume of the body will be W by ρ1, because the weight of the body is given to be W kgf. This means that the mass of the body is W kilogram. So the volume of the body is W by ρ1 meter cube, and this multiplied by the density of the liquid is ρ2. So this is W ρ2 by ρ1. This is this much kilogram force is the upthrust. Okay. So what will be the apparent? The concept is that the thrust that is acting on the bottom surface of the container, that will be due to the apparent weight, that is W dash. Now this is W. What is Fb? Fb is W ρ2 by ρ1. If I simplify this becomes W multiplied by ρ1 minus ρ2 whole divided by ρ1 kgf. Okay, so this is the apparent weight which is acting as a thrust on the bottom surface of the container. So what will be the pressure due to this body which is completely immersed, that is, it has sunk? What will be the pressure on the bottom surface of the container, it is given that the area base area of the body, so cylindrical body is a meter square. So the pressure will be the total thrust which is due to the apparent weight W dash divided by A. This is W multiplied by rho 1 minus rho 2 whole divided by rho 1 and this whole by A. So this becomes W multiplied by rho 1 minus rho 2 divided by rho 1A. This much kgf per meter square will be the pressure. Now all the choices are given in Pascal. So we know that 1 kgf 1 kgf per meter square, 1 kgf is equal to 10 Newton. So this will be 10 W if I consider the acceleration due to gravity g to be 10 meter per second square. So rho 1 minus rho 2 divided by rho 1A, this much Pascal. So the pressure will be 10 W multiplied by rho 1 minus rho 2 divided by rho 1A. So the correct choice is choice C. C is the correct choice. If you find difficulty in understanding any concept that I am applying or any steps, any formula, then first I will recommend you to watch the video where I discussed about the concepts and formula based on which I am solving these problems. If you still have any problem, query, question, then please feel free to let me know in the comment section. I will do my best with the best of my ability to address your query. Okay, let's see the next problem. Question number 2. An elephant weighing x kilogram force has an area of y meter square of each of his foot. Okay, if the elephant stands on his 3 feet, then the pressure exerted on the ground is. Let's quickly draw an elephant. Okay. So the elephant is let's say the elephant is standing on 3 feet. Okay, let's say the elephant is standing on 3 feet on the ground, so 1 foot is up anyway. Okay, so the area of each foot, the area, that is the area of contact of each foot with the ground, is given to be y meter square. Okay, so the weight of the total thrust that the elephant is applying on the ground is due to the weight. So the force here is x kgf, which is equal to 10x Newton. That is this is the total force acting vertically downwards on the ground, that is the thrust. What is the total area area of contact that the elephant is having? The total area of contact will be the area, the 3 into area of each of his foot. So this will be 3y meter square. Hence the pressure the elephant is exerting on the ground will be F by A, the total weight of the elephant divided by the net area of contact. So this is equal to 10x by 3y Newton per meter square. So this is equal to 10x by 3y Pascal. 10x by 3y Pascal is the pressure. So the correct choice is B. B is the correct choice. Let's see the next problem. Question number 3. A solid cuboid of mass m kilogram and dimension 4 meter is to 5 meter is to 4 meter is to 1 meter exerts a maximum and minimum pressure of x Pascal and y Pascal respectively when it rests on one of its faces on a flat surface. Then find the values of x and y. Okay, so from the dimension of a cuboid and its weight, we can easily find what will be the maximum pressure. The maximum pressure will be when the cuboid is resting on the side which is having the minimum area. So if I consider A mean to be the minimum area of its face, it will obviously will be 4 meter multiplied by 1 meter, which is equal to 4 meter square. Similarly, the maximum area of its faces will be 5 meter multiplied by 4 meter, which is 20 meter square. So clearly the thrust, the force that is acting that is acting on the surface by the solid cuboid, irrespective of which face, on which face it is resting, that force will be its weight, which is m kgf. The mass is given as m kilogram, so the weight of the force of the thrust will be m kgf, which is equal to 10 m Newton. Since we know 1 kgf is equal to 10 Newton, if we consider the acceleration due to gravity, value of g is 10 meter per second square. This 10 could also be 9.8 if you consider the value of g on the earth surface to be 9.8 meter per second square. Okay, so now the force is same, the force is constant, which is due to the weight of the solid cuboid. So what will be the maximum pressure? P max. The maximum pressure will definitely be when the area is minimum. So this is F by a mean, which is equal to 10 m Newton divided by a mean is 4 meter square. This after simplification becomes 5 m by 2 Newton per meter square, which is equal to 5 m by 2 Pascal. So this implies in the problem it is given the maximum pressure is x Pascal. So we have x is equal to 5 m by 2. So x is 5 m by 2. So clearly we can reject choice B and C. So now we have to find what is y. That is, we have to find the minimum pressure. P mean will obviously be equal to F by A max. This is equal to 10 m Newton divided by A max is 20 meter square. This is equal to m by 2 Newton per meter square, which is equal to m by 2 Pascal. So this implies y is equal to m by 2. So y is equal to m by 2. Hence the correct choice is A. A is the correct choice. Okay, let's see the next problem. Question number 4 says we are having two figures. Figure A, we are having a container. There is a liquid. The density of the liquid is rho and the height of the liquid column is h. And the first figure is on the earth surface where acceleration due to gravity is given to be g. Okay. In the second figure B, we are having another container and there is liquid having density 3 rho and height of 3h by 2. The height of the liquid column is 3h by 2, and this is on the moon surface where acceleration due to gravity is g by 16. Okay. So in figure A, pressure in figure A, pressure exerted by a liquid column of height h and density rho is Pe. And in figure B, the pressure exerted by a liquid column of height 3h by 2 and density 3 rho is Pm. Pe means E for earth and M and Pm, M for moon. Then which of the following statements are correct? So we have to find Pe and Pm and compare them. Fine. We know that for a liquid column, the pressure is equal to the height of the liquid column, the density of the liquid multiplied by the g. Whatever the g is at that location point, g is the acceleration due to gravity, whose value is on the earth surface 10 or 9.8 meter per second square. This is the basic formula of the pressure of a liquid exerted on the bottom surface of a container where the height of the liquid column is h, density of the liquid is rho, and g is the acceleration due to gravity at that location. So clearly we can show PE pressure on the earth surface. PE will be H, rho and G, and PM will be 3H. The height of the liquid column is 3H by 2. The density of the liquid is, it's a different liquid, so density is 3 rho, and the G is given to be G by 6. This is equal to 3 by 4 H rho G. So PE is H rho G and PM is 3 by 4 H rho G. Clearly we can see this implies that PE is equal to 3 by 4 times PM. Sorry, it's other way around. I'm sorry. PM, we can see that PM is equal to 3 by 4 PE. Okay, so this implies definitely that PM is less than PE. If PM is equal to 3 by 4 PE, then definitely, since 3 by 4 is less than 1, we must have PM less than PE, or PE is greater than PM. So clearly choice C is correct. Now by mistake, wherever actually I intend also to make the choice D correct, but while solving it I incorrectly found that PE is equal to 3 by 4 PM, but actually it is PM equals to 3 by 4 PE. So for these choices, choice C is only correct, but originally I also intended choice D to be also correct, but I incorrectly solved that PE is equal to 3 by 4 PM, where actually it is PM is equal to 3 by 4 PE. So anyway, for these choices only choice C is correct. So we have PM is equal to 3 by 4 PE, and from this fact we can obviously say PE is greater than PM. Okay, let's see the next problem, the last problem. X Pascal pressure is applied on the head of a nail placed perpendicular to the surface of a ball. If the area of cross section of the tip of the nail is 1 by y times the area of cross section of the head, the pressure exerted on the ball is. So the concept is that when you hammer a nail, this is the head of the nail, and let's say this is the nail and this is the ball. So the area of the head, let's say, be capital A, and it is given that the area of the tip, that is the other end of the nail, is 1 by y times area of cross section of the head. So this will be A by y. Let's say, okay, A by y. Fine. Now it is given in the problem that X Pascal pressure is applied on the head of a nail. So definitely some force might have been applied when the nail is being hammered on the head. Then some force is being applied. That force is essentially creating the pressure, which is given to be X Pascal. So I know pressure is equal to force by A. This implies, since the pressure is given to be X Pascal, so we have X is equal to, we have F by, we have assumed the area of cross section of the area of the head to be A. So this implies the force being applied on the head is equal to XA. This is the where we have assumed that the area of the head is A. The force is being applied is on the head is F. Now this same force is also being applied by the tip of the nail on the surface of the wall. So clearly the pressure exerted by the tip of the nail on the surface of the wall will be the force will be same divided by the area of the tip, which is A by Y. This is Fy by A. And what is F? F we have found to be XA. XA Y by A, this is equal to XY. So the pressure exerted by the tip of the nail on the surface of the wall is XY Pascal. So the correct choice is C. C is the correct choice. So this was some sample problems that I framed based on the concepts of finding the pressure exerted by solid structures and liquid columns that I discussed in the previous video in part 9. If you find this video beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think I have completed the entire chapter of force and pressure regarding numerical problem solving. If you think I have left out any concept, then please feel free to let me know in the comment section. I will definitely make videos on those concepts. Now the next video I will be on some new chapter which I don't know. I will see. So I will end the video here. Thanks for watching, and until the next video, take care and bye.